Hey guys, welcome to our new project. Yesterday you guys kind of finished up putting the marble sorter design stuff online. I had you do that because most of you did it before we left, and I wanted to make sure we just kind of finished up those design parts. But it's not like we can start building our marble sorters. So we are gonna jump to our choice project. I know I talked about that with some of you guys. We're gonna do it at the end of the year. I know some of you guys were getting super pumped, but we're gonna do it now instead. This is a good time for us to try new things we wouldn't have been able to do before. So I wrote up a new choice project for us. So before we start on our choice project, and I know you can't do this from home without the materials, but I wanted to just give you an inspiration, give you some inspiration. I saw this video, Mr. Murphy actually showed it to me, and I thought they did a great job of just thinking of a fun project and going for it and learning throughout that. This project took the guy 3 years, so I'm not thinking we'll do something like that, but I just wanted to kind of show you. So it is automatic bullseye moving dartboard, and there is the YouTube link, and I'm gonna go ahead and pull that up now. Oops. Here we go.
Any comments, Doug?
Sorry about the ad.
Only pay for what you need with Liberty Mutual.
Doug, where are Luna's pants?
You'll have to ask Lena.
I suck at darts, but I'm good at it.
Sorry about that, guys.
I suck at darts, but I'm good at engineering, which means I'm actually really good at darts. Most of the projects and builds for my YouTube channel take a month or two to pull off, but I've been working on this beast with my former NASA coworker John for over 3 freaking years, and here she finally is.
So we might
it's fairly self-explanatory, but you throw a dart, and as long as your initial throw is somewhere within this diameter or so, the dartboard helps out a little bit.
Looks like it helps out a lot.
And what's cool is if you use this dart, it will make you the world's best dart player because you get a bullseye nearly every time. And even if you don't, it's really close. But if you use this dart, it makes you the world's worst dart player because it calculates the initial trajectory and then moves the board in the exact opposite direction. So eventually we took this thing to a bar to see if it would work in the wild. But before we get to that, let's talk about how it actually works. Fundamentally, there are 2 main parts to the system. First, you need to somehow predict where a dart is going to land with a typical throw from regulation distance. And you have about 200 milliseconds to do that. And then second, you need to somehow move the board to that predicted location. And you have about another 200 milliseconds to do that. So let's start with the first part about how we predict where the dart's going to land. So the real secret here is that our dart has these tiny retro reflectors on it, and then we have a Vicon motion capture system. As humans, we can see in 3D because we have 2 eyes, and our brain calculates the difference between the 2 images and then tells us how far or close things are. This is why if you close one eye, you instantly lose that depth perception. So that's basically what we're doing here, except we have 6 eyes all around the room, and each of these eyes, or cameras, can take a 4K resolution picture 260 times per second. But since it's hard to visually separate something so small, moving so fast in front of a busy background, they actually use IR. So they blast out IR from all these IR LEDs, and then it hits the retroreflectors and then bounces back to the lens. So when I wave the dart around like this is what you and I see, but the motion capture system just sees a solitary dart floating around. One of the reasons this board took us so long to build was that for the first 2 years we were trying to make our own motion capture system. So we had our own cameras and one of these awesome NVIDIA TX1 boards, which is basically like a Raspberry Pi on Russian steroids. But it turns out it's a super complex problem to solve all, and the Vicon system was just turnkey. So now that we have the XYZ position of the dart as it travels through the air, we use some MATLAB code to then predict where it will land. And the trick here is that anything you throw into the air, neglecting air resistance, will travel in a perfect parabola. Even something you wouldn't think of, like a high jumper, if you track their center of mass, it actually follows a perfect parabola shape. So we used our understanding of parabolas, and from a side view, we use that to predict the final up and down position of the board. And then to predict the final left-right position of the board, we know from a bottom view, a dart will follow a linear path. So we use good old y equals mx plus b, and the y-intercept, or b in this case, tells you how far to move it left and right for the final position. So now that we know exactly where to move, let's talk about how we actually do it. So the board itself is on two linear sliders, which allows it to translate to any specific location. So that provides the track on where to move, but the engine would be these 6 stepper motors you can see from the front. Each motor has a spool and then some fishing line, and they all attach to the center of the back of the board right here. Once we have the predicted bullseye spot, the computer does the trigonometry and then sends the commands over here to the motors. So to move to the left, it would say like, you need to spin up, but you need to unspin at the same rate. And on the back, you can see the computer signal comes into this Arduino compatible board here, and then you got some preamps here that bump up the voltage signal to the 6 individual stepper motor controllers. And these stepper motor drivers take the moving instructions and combine it with the power from the plug in the wall after it goes through this AC-DC power converter. And then finally, a bunch of voltage pulses from the motor controller cause the motor to take small steps and either wind up or wind down. Now keep in mind, all of this happens in less than half a second and allows us to hit our sub-millimeter precision in our board positioning. Oh, and we don't just make one guess on the final position of the board. We update and refine that guess anywhere from 10 to 100 times, which is why sometimes you sort of see the board jitter into the final position. So we took it to a bar to see what people thought. In general, we found if you're really drunk, you get so pumped at your new abilities, if not slightly confused.
I used to suck at darts!
In a way, it's a curse, but when I get an idea like this, I can't not do it, even if it takes me 3 years and is a...
Okay, so I thought that was, I know it was a little bit long, but I thought that was a good kind of look at trying a new project. I liked what he said at the end there, that he said, when I get an idea like this, I just can't not do it. So hopefully that inspired you guys a little bit. We are going to start our own engineering project. We won't spend 3 years, more like 3 weeks. And I'll attach these PDFs, but here it goes. Principles of Engineering problem statement. So we are going to look at a problem that's up to you. So you have to get it approved by me and let me know, but this choice for the problem statement is up to you. Our constraints are kind of given, though. This sounds like something out of a movie, but it's real right now. The USA is experiencing a pandemic, and the only supplies you can utilize are the ones available to you while you're under the stay-in order. Your supplies can be digital or physical. So things you have around the house, things outside, things on the computer, whatever works there. Then these are the things that you're going to be working on over these next couple of weeks, these deliverables. So step 1, like usual, is our define the problem, which you guys are going to make. Here's kind of the rules. The problem statement and constraints are fully and clearly written. Then you're going to start brainstorming. So generate your concepts. Give me at least 2 brainstorm ideas. Make sure you have descriptions, annotations, that sort of thing. Then you're going to develop your solution. So come up with your final idea. Draw it out, annotate it, explain why you picked this, that sort of thing. Then we're going to start building. Each day, that you'll work on this. You're going to take a picture of what you're working on and write about how you constructed and tested. So each class period should have a description of what was built and or changed, as well as a photo. After that, near the end, you guys will evaluate your solution. Basically type a one-page paper reflecting on these things here. And then last but not least, you're going to present your solution. Since we won't be in school, that will probably be a video that you upload. So that is our project. I'm guessing you'll work alone on this. If you can find a way that remotely through Zoom or something, meeting with a friend, you are welcome to do that. Just let me know how that's going to work out. And again, this is kind of what you're looking at. So some of you guys might have left your engineering notebooks at school. If you did, even if you didn't, Notability is probably my first choice. If you can just sign over things like you normally would, even though it's kind of silly in Notability, and sign at the bottom just to have the look of an engineering notebook. If you do have your engineering notebook, you can take pictures of it. I sent out a survey and a lot of people said they had something that could take pictures, iPads, phones, etc. Or if you want to just do it in a regular paper, write it like a notebook with the signatures and take pictures of it. But if you have Notability, that would probably be the best choice. So again, your steps are define problem, then 2 to 3 concepts, half to a full page. I would say err more on the full page. Drawn and written solution. Your step 4, your construct and test prototype. So each day writing and then a picture. Step 5 is your type paper evaluating your solution, and then your video presenting. So I've attached this rubric as well. It kind of goes through the points for each thing. So this will be the first thing, your concepts, your solution, then each day that you work on it, your paper and your presentation. The presentation is these 5 points right here, but also don't forget to include your notebook that you presented and what kind of happened. And then just a little bit of difficulty and effort points, making sure that you're not trying a lame project. I want to see cool stuff. Timeline. This is kind of what I want you to make a note of. I'm going to put these assignments up every day, so you don't have to remember all of this. But if you want an outline, today we're starting by just having you watch this video. And then I want you to start. Your first assignment will be do the define problem. So that will be due tomorrow. That's our first assignment. Then each day on Classroom, I'll put these up. So on Friday, you'll work on the concepts, which will be due then the next Monday. Then you will work on Monday on developing your solution, your step 3, writing that in your notebook, which would then be due on Tuesday. Then you get to start building. So each day that you build, it looks like it's going to be 5 different days. Tuesday, block day, Friday, Monday, and then Tuesday. Those 5 days right in here, you are going to write up what you worked on that day and take a picture of it as well. Timeline-wise, the school had said that 9th and 10th should be spending about 50 minutes a day per class, 11th and 12th about 60, and then on block days a little bit more. I don't know, they could change that, but that's the last that I have heard. So if you can aim around there, it doesn't have to be the full 50 or 60. You can go over some days, you can go under some days. You should spend more than, 30 on it. But if you're hitting 45 on those regular days, that sounds great. And writing about it. Then on our black day over here, you're going to type your paper and then take a video of you presenting. And then you are on Easter break. Can't believe it. So that's just kind of an outline for you guys that like to plan ahead. Again, each day I'll put, the assignment for each day. So you don't have to worry about remembering all of that. But there's an outline for you guys. As far as ideas, what are you going to do? What are you going to do from home? I encourage you to think outside the box. Think of something neat that you want to do that you wouldn't have done before. Try something cool. These are some projects that people have done in the past. A Rube Goldberg machine is a good one that you could do at home. One girl used popsicle sticks or tiny balsa wood, and her grandpa was an architect, and she found some old drawings of his and rebuilt a house that he designed. That was really neat. This hydraulics drawbridge, they took popsicle sticks and they kind of built a drawbridge with hydraulics to open it up. This was somebody last year. They took a container at their house and a pump and pulled out all the air to vacuum seal it. Then they put a couple of peeps. Let me try to draw this. They were Easter peeps. And there's my bunny. They put the peeps in there, pulled the air out, and they looked at how the peeps change sizes. So those are a couple of ideas for you. I also researched some stuff online just to give you guys a couple of ideas. So the things that I found, here was some Rube Goldberg ideas. I kind of love those. Somebody had done one in the past, and those are a cool thing you could do from home. You could build a catapult. There's some small ones. There's a pretty big one. That would be awesome. I've been watching Lego Masters a lot, and they, on the last episode, built some pretty cool Lego bridges. So if you have Legos at home, that's something you could do. Popsicle stick bridges, again, are always a good idea if you want to amp up yours from the past. The other thing is, if you're interested in programming, I saw some other Project Lead the Way teachers in other schools were doing this, and it's basically teaching yourself to code online. Because of times like this, they have given me access to the teacher side of it, and the student side is free, so that you can use that. If you're interested in that, I wanted to just kind of see what it was. They have a lot of cool curriculum. If you want to take an AP computer science class and just get ahead on that and see how much AP Comp Sci you can learn on the side, you could do that, or anything. Oh, they have these if you want to learn to write code for apps. That's a cool one as well. And then I loved these down at the bottom. They had hour of code. So if you just want to learn an hour here and there of Java and mobile apps, and this one was basically getting this dog to do different program designs. So there is a lot of cool, if you want to do web design or graphics, this looked like a neat one as well if you're interested in computer science. So those are just some ideas. Let me know what you come up with. Your very first assignment for today is just going to be to define your problem and watch this video. So you're almost done watching this video. And do step 1 in your notebook. Define the problem, get it approved by me. You can write it in Google Classroom on the comment section, or you can email me, whatever works for you guys. Here we go. This is going to be crazy, but it's going to be fun. Do something cool. See you guys soon. Bye-bye.